Hi, we are on page 8b and 9. So you can see the little 9 down here. And this is how you're going to set up your pages. I know it's sideways. I apologize for that. But you do need to write your goal up here. I can model data using a scatter plot and analyze the data. So write the goal at the top of page 8b, and then you're going to write these 4 words: scatter plot, bivariate data, independent variable, and dependent variable. And this will be your first part of getting this page set up. So you fold the pages in half and glue in the back. Next, when you open your first page, you will have this. We're going to talk about what happened to California's population during the gold rush. Well, maybe we will. Yeah, so what happened to California's population during the gold rush? It says use the bivariate data below to create a scatter plot. Use different colors for each set of points. So on our first plot, we're going to make it the color green. Now, by now you should have defined the word independent variable, and that is going to normally be your time, and it will be your x-axis. So in this case, that's going to be your year. Time is independent. Nothing that we do changes time. And so these years, this is our independent variable. Our dependent variable for our first plot is going to be the Native American population in California. So you'll see that information. Our second plot, we're going to make it pink or whatever color highlighter you have. And our independent variable is going to be the same. We're still going to go with years. And our dependent variable is going to be the census information for California. So we have those 4 points. Okay. Then, how can we scale the graph to represent this data correctly? That'll be easier to check in on the next page. So let me show you that page. Oh, sorry. So when we look at the scale, I always like to use the same grid. And so I started here at 1750. And then if you think about every one little line as a decade, when you get to this next solid line, it would be 1800. So then the next darker bolded line would be 1850, 1900, 1950. So you can see every little line is 10 years, but it would be really hard to label every little line. And so I use this so you only have to label the big lines, the bolded lines. So your X value is best to go by decade: 1750, 60, 70, 80, 90, 1800, 1810, 20, 30, 40, 50, and so on. Then when I looked at my table, I had a number that was more than 1,400,000. So I knew I needed to get it at least up that far. And so I didn't have to do all of the zeros. I use the K for thousand. So this is 200,000, 400,000, 600,000, 800,000, 1 million, 1,200,000, 1,400,000, and 1,600,000. And then, so what that does is for your y-axis, every little line goes up by 40,000. So it's 40,000, 80,000, 120,000, 160,000, and 200,000. 220, 240, or I'm sorry, 240, 280, 320, 360, 400. And so 40,000 is your little spaces. So when you go back and forth between plotting the points, you're going to look at the data, and your X value, remember, was your year, and your Y value is the number for the population. So when I go back to here, you'll see that in 1770, there were 310,000 Native Americans in California. So to plot that, oops, my goodness, sorry about that. To plot that in 1770, so remember this is 1750, 60, 70, and it said 310,000. So here's 200, 240, 280, and then 320 would be the next line, so it's just below that. So I plotted a point there. All of my first points are green. So you can double check, make sure you get your points plotted. And then my other points are pink. This is the census population. And so in 1845, the census population said that there were like 8,000 people living in California. And then you'll see that it pops up pretty quickly there. And you'll be talking about in social studies why that happened. Clustering, I don't really see any clusters because these are one of them is the green dot and one's the pink dot. So I would say there's no clusters. There's no big groupings of points. When you look at the Native American population, you see that it stays pretty close together, but then it drops dramatically. So it's nonlinear because of the shape it makes. And since most of the time it's going down, well, all the time it's going down, it has a negative association. But when you look at your census data, looking at the people that they were counting in California, so the settlers, then when you look at it, you'll notice that it goes up very, very quickly. So it has a positive association, but where it starts off slow and then it comes so fast, it would still be considered nonlinear. The last thing for you to see is if you did not get the definitions, I want to make sure you have those. And so here they are. You can look at the definitions. You can find these on the links that I provided in class. So you can pause the video now to make sure you have them all done. Thanks.